Hello everybody and welcome back to Algebra 2. Today we're going to be talking about 2-2 direct variations. Let's get started. Vocabulary and review. Number 1. Cross out the ratio that is not equal to the others. We have 3.5 over 1, 7 over 2, 10.5 over 3, or 9 over 4. Which one of these are not like the other ones? Well, 3.5 divided by 1 is strictly going to be that. It's going to equal 3.5. And if we take a look at 7 over 2, again, we get 3.5. 10 over 5 will also be 3.5. And the only one that seems to not be 3.5 will end up being the 9 over 4, which is actually the same thing as 2.25. So the answer should be 9 over 4. Solve each proportion. 3 over 2 equals 9 over x. Well, you can kind of do the cross multiplication that everyone always likes to do. So the 3 times the x has to equal the 9 times the 2. So we have 3 times x equals 9 times 2. So 3x equals 18. Divide both sides by that 3. And you'll end with that 18 divided by 3 is 6. So x equals 6. We do the same thing right here, cross multiplication. We'll get 12x is going to equal 3 times 16. Well, that's going to be 30 plus 18, which is 48. We're going to divide both sides by 12. And then you'll get x is going to equal 4. Again, cross multiplication. 7x has to equal 2 times 5, which is 10. Divide both sides by 7. And you'll get that x will equal 10 over 7. And last but not least, you have 9x equals, well, 2 times 18 is going to give you that 36. So we have 9x equals 36. We are then going to divide both sides by 9. And when you divide both sides by that 9, you'll get that x is going to equal 4. So let's talk about the second portion of the vocabulary section. We're going to be talking about the word direct. Other forms of this word might be like the adverb version, which is going to be the directly, or the plural noun, which is directions. All right. Main idea is basically that direct describes two quantities that vary in the same way, increasing together or decreasing together. Definition: something that is direct is proceeding from one point to another in time or space without interruption. So let's choose the correct word from the list to complete each of these sentences. We got directly, direct, or directions. Thomas gave the visitor blank to the stadium. Well, the one that I would pick would be directions. Gave him directions to the stadium. The fans went directly to their seats. And there was a direct connection between the teams scoring and the fans cheering. Problem 1. Identifying direct variations from tables. For the table at the right, determine whether y varies directly with x. If so, what are the constant of variation and the function rule? Let's first start by writing the ratio of the input-output pairs in its simplest form. If we have negative 21 divided by 3, that is going to be the exact same thing as negative 7. Well, right here we have our 2 on the bottom, as our 2 is in our x value. So we have a negative 14 divided by 2, which gives you a negative 7 as well. And last but not least, we are going to be putting a 1 or x value in the bottom once again, and we're going to be putting the y value on top, or the output on top. The negative 7 divided by 1 is going to equal negative 7. Now, underline the correct word or words to complete the sentence. Since the ratio y over x is in fact the same for all of the input-output pairs, the function is going to be a direct variation. If possible, identify the constant of variation and write the function rule. Well, since this is a direct variation, we can find the constant, and it's going to be based off of the constant change that seems to be happening, which happens to be that negative 21 divided by 3, which is the negative 7, the negative 7 from the negative 14 over 2, and the negative 7 from that negative 7 divided by 1. So the constant is going to be negative 7, or the constant of variation, which means that the number that we're multiplying by that x value will also be negative 7. And you should start to notice that this looks awfully familiar, doesn't it? It's almost like we're starting off the y equals an mx. We're just leaving off that plus b portion. All right? So we are going to be kind of talking about the slope when it comes down to the direct variation. Good work. Problem number 2, identifying direct variation from equations. Well, for the function 5x plus 3y equals 0, determine whether y varies directly with x, and if so, what is the constant of variation? The very first thing is we need to make sure we solve for y. If I rewrite this as 5x plus 3y equals 0, we need to get y by itself. I'm going to move everything away from that y as fast as I can. I'm going to subtract that negative 5x to the other side, which will cancel it right here, leaving us just with what we bring down, which is that 3y is going to equal a negative 5x. And then finally, we have to make sure we divide by 3 to get y completely by itself. Now, when you divide by 3, you'll get that y is going to equal a negative 5/3 times x. Notice, yes, it is negative 5x divided by 3, but when you write it like this, you can start to see the constant of variation, because notice, there is nothing that we're adding to this value, so this is going to be a direct variation. So y does in fact vary directly with the x value. So we must circle the constant of variation. Well, that's going to be what we see right here, was that negative 5 divided by 3, which means that this constant of variation will in fact be that negative 5 divided by 3. Problem 3. Using a proportion can actually help you solve a direct variation. So suppose y varies directly with x, and we know that y equals 15 when x equals 3. Well then, what is y when x equals 12? We can complete the proportion below, right? So if we put 15 divided by 3 is going to equal our y value divided by, in this case, it's going to be 12, right here. We can then turn this into a cross multiplication, and we can simplify this out. So we are going to get 15 times 12 and 3 times y. So we're going to know that 3 times y must equal 15 times 12. So we know 3y is going to have to equal 3 times 5 times 12, because 3 times 5 is in fact 15, and there is a reason why I'm picking it like this, because I know that 5 times 12 is in fact 60, and 60 is a little bit easier to multiply between 3 than it is for me just to say 15 times 12. So 3 times 60 is going to be the same thing as 3 times 6, which is 18, and then we're adding a 0, so I know it's 180. So we get 3y is going to equal 180. And this actually helps us out a little bit, because the very next step that I must do is divide everything by 3, because we need to get y by itself. So we now know that y is going to equal, in fact, 60. Because 180 divided by 3 equals 60. So when x equals 12, the y value is going to be 60. Now, we have to kind of have an idea if that makes any sense. Well, if you were to take a look at this, you would see that when we have x equals 3, y is going to be 15. Well, 3 times 5 gives you 15. Well, if we were to multiply that same number by 5, so that 12 by 5, you will then get 12 times 5, which is also, like we said before up here, 60. So it does work. Problem number 4. Using a proportion to solve a problem. Well, the number of calories varies directly with the mass of cheese. If 50 grams of cheese contains 200 calories, How many calories are in 70 grams of cheese? Let's complete the model below, and we're going to let C equal the calories. So the ratio of 200 calories to 50 grams is going to be the same thing as the ratio of C calories to 70 grams. So if we have the 200 calories to the 50 grams, it's going to become 200 divided by 50. And then we have the ratio of C calories to the 70, so the 200 is now going to be replaced with the C, because that's the number of calories, and that's going to be over the grams, which happens to be 50 in the first one, and it now becomes 70 in the next. So let's solve this proportion. Again, we're going to make sure we cross multiply. So the 50 is going to be multiplied by the C, 50 times C, which is going to have to equal 70 times 200. So 70 times 200, if we were to multiply those out, I can just remember that we have 3 different zeros, and then we have 7 times 2, which is 14. So it's going to be 14,000. So we'll get 50C is going to equal 14,000. We then must divide both sides by 50 because we're trying to get that calorie count, or the C value, by itself. So we'll now get that C is going to equal 280. And therefore, there are about 280 calories in 70 grams of cheese. Problem number 5. Graphing direct variation equations. What is the graph of the direction variation equation y equals negative 2 over 3x? Complete the table. Well, if I know that x equals negative 3, then I can say that we have negative 2 over 3 times a negative 3. And these 3's will cancel out. And in fact, the negatives will also cancel out, leaving you just with a positive 2. If I plug a 0 into this equation, we now have negative 2 times 0, which is 0. And if negative 3 was positive 2, then I'm going to assume that positive 3 will probably end up being a negative 2. But let's check just to make sure. So we have a negative 2 over 3 times your 3. The 3's cancel out, leaving you just with the negative 2. So 3 is now going to become negative 2. Well, let's graph the direct variation. If you go back to the negative 3 on the x value, you have to go up to a positive 2 on the y value. You have a point at 0, 0, which is in fact on the origin right there. And then if you go to 3 on the x value, you have to go down 2 on the y, and you'll get something that looks like this. And if I were to graph it out completely, you'll have something that looks like this. It'll be a straight line cutting through the origin, which is also very important because every direct variation will always cut straight through the origin, or the point 0, 0. Congratulations, we made it to the lesson check. We're almost done, everybody. So first, let's talk about the reasoning. We're going to explain why the graph of a direct variation function always passes through the origin. So question number 22. Write direct variation if the graph is a direct variation. Write linear if the graph is a linear function and is not a direct variation. So again, the graph has to always pass through the origin. I said it in the previous slide. It's saying it up in the top portion as well. I'm going to say that the two graphs right here and here happen to pass through the origin, which means that this graph is in fact a direct variation. The second graph is also a direct variation, even though this one is going in a negative pattern, whereas this one's going positive, or going up in a positive slope. They're both direct variations. The final graph that is shown is going to be a linear graph. So this is going to be a linear function. Question 23. Write D if the equation describes a direct variation, and write L if the equation describes a linear function, which is not a direct variation. Well, the major difference is the fact that when you have a linear function, it can pass through any portion on the y-axis, meaning the y-intercept is constantly changing, which is why you'll start seeing numbers being added or subtracted at the end of a linear function. However, a direct variation must always pass through the origin. like I said in the beginning portion, it needs to pass through that origin, which means that the y-intercept for any sort of direct variation is going to be 0. And what happens when you add 0? Well, it doesn't change anything. And since it doesn't change anything, we don't have to worry about writing it. So y equals negative 2x, that is going to be a direct variation. Y equals x, again, we're not adding a y-intercept at the end because it's a 0, which means that this is also a direct variation. However, the very last equation given, we have the y equals negative 2x plus 2. That plus 2 is what turns this into a linear equation. A linear equation that is not a direct variation. Now we must circle the true statement. A linear function is always a direct variation. Or, a direct variation is always a linear function. Well, if this first part was true, we wouldn't have to figure out the difference between the just direct variation or the linear functions. So, for this answer, the true statement is going to come from a direct variation is always a linear function. No matter what, this can be written as a linear function because it creates a line. It's a linear function on a graph. It just has a special name because it happens to pass through the origin. Whereas a linear function that doesn't pass through the origin will never be considered a direct variation. And that is why we can't say the beginning portion is true. The equation for the direct variation with the constant of variation k is going to look like y equals k times x. Now we must evaluate the function you wrote in the exercise 25 for x equals 0. In other words, we're going to plug a 0 in for that x. And if I were to plug a 0 in for that x, you'll get y is going to equal k times 0, which means y is going to equal 0. So why does the graph of the direct variation function always pass through the origin? Because 0, 0 is always going to be the solution for y equals k sub x. And that is it, everybody. Congratulations. Great work. I hope you have a wonderful day. Stay out of trouble. Don't do anything stupid. And I'll see you in the next one.